Hello again, grade 11, and welcome to week 7 of our online class. So for General Mathematics 11, week 7, our topic is all about the properties of logarithm. For the learning objectives, at the end of the lesson, you must be able to, number 1, distinguish logarithmic function, logarithmic equation, and then logarithmic inequality, and then solve logarithmic equations and inequalities. Okay, so let's have different properties of logarithm. So the properties of exponents have corresponding properties involving logarithms. So for any base which are b is greater than 0 but b is not equal to 0. Let's have the different properties. Letter A, logarithm of x to the base of b is equal to the logarithm of y to the base of b if and only if x is equal to 1. X is equal to y rather. Okay, next one. Logarithm of b to the base of b is equal to 1. Next, logarithm of 1 to the base of b is equal to 0. And then lastly, logarithm of b raised to x is equal logarithm of b raised to x to the base of b is equal to x. So let's apply the different properties of logarithmic. Number 1, I have here logarithm of 2x plus 10 to the base of 2 is equal to logarithm of 8 plus x to the base of 2. So it will be like this. Since we have here with the same logarithmic, we just need to cancel this out. Cancel logarithm of 2, logarithm of to the base of 2. So we will have 3x plus 10 is equal to 8 plus x. And then combining like terms, we will have 2x minus 2, so this is 2. And then dividing both sides, we will have x is equal to negative 1. Next example, we have here logarithm of 4m to the base of 2 is equal to logarithm of 2m minus 10 to the base of 2. Again, cancel the logarithm. We will have 4m is equal to 2m minus 10. And then combining like terms, transpose 2m to the left side of the equation, we will have 4m minus 2m, which is positive 2m, and then equals negative 10. Dividing both sides by positive 2, we will have m is equal to negative 5. Next one, I have here logarithm of 3x plus 2 to the base of 5 is equal to the logarithm of 2x squared to the base of 5. So, cancel the logarithm. We will have 3x plus 2 is equal to 2x squared. Okay, so since within this given, we have here quadratic or squared as the highest exponent. So therefore, we need to have two values of x. So we just need to arrange it from the highest to lowest. So 2x squared minus 3x minus 2 is equal to 0. So you can use different ways. So number 1, you can use factoring method. You can use completing the squared. You can use quadratic formula for you to get the value of the x. Okay, so since this example is factorable, so I have the factors, which is 2x plus 1, and then the other one will be x minus 2. And then getting the values of x, we will have, the values will be negative 1/2, and then the other one will be x is equal to positive 2. Okay. So let's have the additional property of logarithm. For any positive real numbers, u and letter v, the following properties are true. Letter A, we have here the so-called product law. When we have the product law, we can write the logarithm as like this. So we have here logarithm of u multiplied by v to the base of b. So we can write this one as logarithm of u to the base of b plus logarithm of v to the base of b. Okay, so we can separate or expand this logarithm into its expanded form with the use of this property or the product law. Okay, so we just need to put or insert positive or plus sign to state that it is factory or it is product or multiplication of logarithms. Next one, we have here the so-called quotient law. For example, I have here logarithm of u over v to the base of b. So we can expand this one as logarithm of u to the base of b minus logarithm of b to the base of b. So the difference between the product law and then the quotient law is just the operation to be used. When we have the product law or the multiplication, we just need to use plus or addition, and then if it's quotient or division, we need to use minus as the sign for the expansion. And then last one, we have here the power law. Okay, so for example, I have here logarithm of u to the base okay, again, we have here logarithm of u raised to n to the base of b. We can write this one as n logarithm of u to the base of b. We can put the exponent to the first part or on the beside the logarithm, okay, before the logarithm. So for example, I have here the exponent, which is n. So put it beside logarithm before the logarithm. So n logarithm of u to the base of b. Let's have different examples. Expand the following. Number 1, logarithm of u times v squared times w cubed to the base of 2. Okay, so we just need to expand it. So in getting the expansion, we can expand it using logarithm of u to the base of 2 for u, logarithm of v squared to the base of 2 for v squared, and then plus logarithm of w raised to 3 to the base of 2 for this part. Okay, so the reason why we're using addition or plus, because we have here multiplication. And then using the power rule or the power law, we have here logarithm of u to the base of 2, and then 2 logarithm of v to the base of 2, and then the last one will be 3 logarithm of w to the base of 2. So next one, expand logarithm of x cubed over y squared to the base of 9. So since we have quotient, so therefore we're going to use subtraction. So that will be logarithm of x cubed to the base of 9 minus logarithm of y squared to the base of 9. So we can use power law, power rule, or power property. So 3 logarithm of x to the base of 9 minus 2 logarithm of y to the base of 9. Okay. Another examples. I have here logarithm of cube root of a, b, and c to the base of 3. So we can write it as logarithm of a, b, and c raised to 1/3, because cube root, we can write cube root as fractional exponent, which is 1/3. For example, we have fourth root, we can write it as 1/4 as the exponent. For the square root, we can use it as raised to 1/2. Okay, so we can use this one, logarithm of a, b, and c to raised to 3 to the base of 3. So put 1/3 on the first part, so logarithm of a, b, and c to the base of 3, and then expand a, b, and c using the logarithm. So 1/3 times logarithm of a to the base of 3 plus logarithm of b to the base of 3 plus logarithm of c to the base of 3, or we can write it as logarithm of a to the base of 3 over 3, because we have here 1/3, logarithm of b to the base of 3 over 3, and then logarithm of c to the base of 3 over 3 for letter C. And then for letter D, we have here logarithm of 5xy over 2x plus y to the base of 4. So we can write it as logarithm of 5xy to the base of 4 minus logarithm of 2x plus y to the base of 4. So logarithm of 5 to the base of 4 because of this one, and then logarithm of x to the base of 4 for this one, and then for the y, logarithm of y to the base of 4 minus logarithm of 2x plus y to the base of 4, because we have here the quotient. Okay. Let's have another example. I have here 12 logarithm of x to the base of 3, 12 logarithm of z to the base of 3, minus 3 logarithm of y to the base of 3. Okay, so we can write it as logarithm of 3, and then 12 logarithm of x to the base of 3, we can write it as x raised to 12. So x raised to 12, and then multiply it because we have here addition, so therefore we have product. So z raised to 12 minus, which means quotient. So we need to place it on the denominator. So minus 3 logarithm of y to the base of 3. So over y cubed. Next one, I have here logarithm of logarithm of q to the base of 8 minus 3 logarithm of r to the base of 8 plus 5 logarithm of s to the base of 8 and then minus 7 logarithm of t to the base of 8. So again, since we have here minus, therefore we need to insert it or put it on the denominator. So since this is positive, so we need to put it on top. Q and then r raised to 3 for the denominator since we have minus 5 logarithm of s to the base of 8 because it's addition, so therefore we need to multiply it on the top. And then minus, so it will be on the denominator. So 7 and then logarithm of t to the base of 8. So t raised to 7, so it will be like this. Okay? So again, for addition or plus, it will be about multiplication on the numerator, and then for the minus or subtraction, it will be placed on the denominator. Okay. So that will be all for this week, grade 11, and see you on my next video.